On average, every Malaysian produces 0.8 kg trash every day. In Malaysia, the waste produced is sent to a landfill or incineration center. The two systems are very popular in Malaysia.
How does a modern landfill work? Imagine a giant plastic bathtub in the ground. Trash is added to the open tub and covered each day with daily cover, such as contaminated soil or ground-up construction debris. As time goes by, more and more trash is piled on, and more highly toxic methane gas builds up as the trash decomposes. This is when you start to get that trash smell. You know the one. Any water that's in the trash, or any rain or snow that seeps through the cover, starts to trickle down through the garbage. When water and waste are mixed, it creates a toxic, poisonous soup called leachate. Leachate contains all the dangerous stuff that's in a lot of what people throw in the trash. The tens of thousands of chemicals, heavy metals, and other toxic materials found in electronics, batteries, prescription drugs, and plastics, just to name a few. Now the leachate, containing these poisons, percolates through the trash and eventually pools at the bottom. One set of pipes collects the liquid and takes it to the collection tank.
To describe backgrounds of leachate formation and its characteristic, to evaluate impact of leachate to environment, to propose a solution to treat leachate and minimize impact of leachate. There are several types of biological treatment system for leachate using aerobic process, which is activated sludge process, lagoons, sequencing battery reactors, trickling filter, moving bed biofilm reactors.
Secondary treatment is the heart of the wastewater treatment process. Whereas the previous steps of treatment consisted in removing the suspended solids by settlement, this step of treatment consists in removing the major part of dissolved pollution, mainly BOD5 and ammonia. During the aeration phase, specific bacteria eat the dissolved organic matter and transform it into suspended solids. Other specific bacteria oxidize the ammonia into nitrates, then nitrates. During the non-aeration phase, called also anoxic phase, other type of bacteria convert the nitrates into nitrogen gas, which is released into the atmosphere. To ensure a good balance between food and bacteria, the bacteria settled in the clarifiers are continuously returned at the inlet of the tank. They are called return-activated sludge. The upstream part of the activated sludge tank is covered so that odorous air is trapped and extracted towards odor treatment units.
Lagoons are a simple method of treating wastewater. Sewage enters the lagoon at one end. The flow entering the lagoon is called influent. Then, it travels through at least one basin of very slow-moving water where pollutants can settle to the bottom of the pond, and good bacteria are allowed to break down many of the compounds that can be detrimental to the environment. Most lagoon systems have multiple sections or cells. Once the water has passed through all the cells of a lagoon, it is typically disinfected with chlorine or UV light and released back into the environment. The flow exiting the lagoon is called effluent. Lagoons are home to good bacteria that digest organic matter in sewage. Typically, the digestion of these organics requires oxygen. The amount of oxygen necessary to break down the organic matter is called biochemical oxygen demand, or BOD. Another property that is monitored for wastewater treatment is total suspended solids, or TSS. Excess suspended solids cause the water to appear cloudy and result in poor water quality. Suspended solids can consist of soil, organic material, and algae. A vast majority of the soil particles settle out of the water by the end of the treatment process. So TSS in lagoon effluent is primarily algae and other organic matter. Lagoons are a great way to treat wastewater and have many advantages over alternative treatments such as mechanical plants. Mechanical plants are expensive to install, require many more man-hours to operate, use far more electricity, and cost much more to maintain than lagoons. Another advantage of lagoons is long hydraulic retention time. Hydraulic retention time, or HRT, is the average length of time it takes for the influent wastewater to reach the end of the treatment cycle. A longer HRT means that more complex chemicals such as pesticides, herbicides, and pharmaceuticals are given time to break down prior to the effluent water being introduced back into the environment. Although lagoons are one of the most cost-effective ways to treat wastewater, lagoons alone cannot keep up with the increasingly demanding restrictions imposed on wastewater effluent. A new technology is needed to improve the treatment capacity of wastewater lagoons.
Part of the original design of this plant. This plant's been upgraded a couple of times, originally constructed. It's pretty amazing to me to see all that big steel structure right there. There's no electric drive turning that around, or no motor. That's all spinning just from the
water has enough pressure
water
to do that?
pushing it around.
Really?
Yeah, that's pretty amazing, I think.
It is pretty cool.
But at any rate, the rocks in this dripping filter are about 6 feet deep. Underneath the rocks there's a support structure and then an open channel underneath that. So the water is going through and
That is cool.
that channel at the bottom. You can see if you look at the distribution arm there, there's a lot more water coming out at the end than there is towards the center. And that's because if I took a 1 foot wide section and followed it all the way around, there's a lot more area on the outside than there is on the inside. So if I wanted to put the same amount of water everywhere, I have a lot lower flow towards the inside. So I use the amount of water.
Let's walk through an example of the MBBR process designed for total nitrogen removal. To begin the MBBR process, influent from the headworks passes through a fine screen and enters the treatment system. Free-flowing biocarriers are distributed throughout individual reactors, and effluent screens act as sieves to keep the biocarriers within each specific reactor. A mechanically mixed anoxic reactor combines the influent stream with a recycle stream from the nitrification reactor. At this point, nitrogen is released into the atmosphere in a process called denitrification. The next reactor is for BOD and/or COD reduction and requires approximately 2 to 3 hours HRT. The high level of carbon food source in the influent stream maintains a rich concentration of heterotrophic bacteria living on the biofilm, which is required for BOD reduction. In the third reactor, the influent has low levels of BOD, limiting the growth of heterotrophic bacteria, and contains high levels of ammonia, supporting the growth of autotrophic bacteria on the biofilm required for nitrification. The nitrification process oxidizes ammonia to nitrates and nitrites in order to meet the required discharge levels. After the MBBR process is complete, clarification removes suspended solids from the treated wastewater. At this point, the effluent is ready for any optional tertiary treatment. The Headworks Bio MBBR aeration and mixing processes produce a continuous sloughing rate, which maintains a more active biofilm. Treatment capacity can easily be expanded by increasing the fill fraction of the biocarriers within the reactor, as much as 70% by volume. At equal levels of BOD removal, Headworks Bio's MBBR provides up to 5 times the biofilm surface area of a trickling filter, using less than a quarter of the reactor volume. When compared to an activated sludge extended air process, MBBR saves time as well as tank space.
Carry on my wayward son. There'll be peace when you are done. Lay your weary head to rest. Don't you cry no more.